In this video, we're looking at balancing chemical equations number 1. So our first equation is N2 plus H2 gives us NH3. So we first need to look for things that are unbalanced. So the first thing I notice here is that nitrogen, there are 2 on the reactant side because the subscript of 2 tells me there are 2 nitrogens here, while there's only 1 nitrogen on the product side, because remember, if there's no subscript, there is a 1 implied next to it. So to fix this problem, I need to multiply the 1 nitrogen over here by some coefficient to give me 2 nitrogens. So that coefficient would be 2, so I'm going to put a 2 in front of NH3. Then I notice that hydrogen is out of balance, and now that I put this 2 here, I messed up whatever hydrogens I had originally. I don't have 3 on the product side anymore. Now I have 2 times 3. So I have 6 hydrogens on the product side. So I need to make 6 hydrogens on the reactant side. So I think, what can I multiply by the subscript of 2 to get me 6? And of course, what times 2 equals 6? Well, of course, that's 3. So I'm going to put a 3 in front of H2. Now I'm just going to go back and check on nitrogen. I already looked at it once, but I'm going to check to make sure it's balanced. 2 times 1, so I have 2 nitrogens on the product side, and then 2 times nothing, 2 times 1 nitrogen on the reactant side. So I don't need to fill in this one, but I like to go ahead and fill in my coefficient of 1 anyway. There's our first equation done. The next one, I have KClO3 equals KCl plus O2. The first thing that I notice is that potassium and chlorine are actually already in balance, and the only problem we have here is the oxygen. But I'm looking at the oxygen, and I think, okay, there's 3 oxygens on the reactant side and 2 on the product side. Is there anything I can multiply 2 by to give me 3 oxygens? And the answer is no. There's nothing I can multiply 2 by to give me 3 oxygens. So when I hit this issue, what I need to do is I need to get an even number of oxygens. So I know that if I multiply anything by 2, that'll give me an even number. So on the reactant side, I'm going to put a coefficient of 2 in front of KClO3. So now I have not 3 oxygens, but 2 times 3, which gives me 6 oxygens. So I have 6 oxygens now, and I know that I can do 3 times 2 to give me 6 oxygens on the product side. Now I need to go back and look at potassium and chlorine. So now that I put this 2 here, I have 2 potassiums and 2 chlorines. So on the product side, I also need to have 2 potassiums and 2 chlorines, so I'm going to put a 2 there as well. Next I have NaCl plus F2 gives me NaF plus Cl2. Now there's 2 things I immediately notice here. I notice that fluorine is out of balance. There's 1 on the products and 2 on the reactants, and also chlorine is out of balance, with 1 on the reactants and 2 on the product side. And I can start by fixing either of these. It doesn't really matter. I'm going to start with chlorine. So I have 2 chlorines on my product side, and I need to make 2 chlorines on my reactant side. So I'm going to put a coefficient of 2 in front of NaCl. Then, by doing that, I have made 2 sodiums, so I'm going to check that on the other side. Sodium, there's only 1 currently, so I'm going to double NaF. And by doing that, I did 2 times fluorine, 2 fluorines, and I already have 2 fluorines on my reactant side. So I'm going to put a 1. And then last, we need to look at Cl2, where there's 2 chlorines on the product side, and we come back over to the reactants to check, and there are indeed 2 chlorines, so I'm just going to fill in a 1 there as well. Number 4, H2 plus O2 gives us H2O. We've looked at this problem a lot. The first thing that we notice is that oxygen is the only thing out of balance. So we have 2 oxygens on the reactant and only 1 on the product side. So I'm going to double H2O by putting a 2 out front. Then I have 2 times 2, so 4 hydrogens on the product side. So I need to double the H2 on the reactant side to make there be 4 hydrogens on the reactant side. And then of course I have 2 oxygens, so I fill in my 1 next to O2. Next we have PbOH2 plus HCl gives us H2O plus PbCl2. So the first thing I note here is that I have a polyatomic ion, and I know this because I have something in parentheses. And then how many of that polyatomic do I have? Well, I have 2 of that polyatomic because this subscript 2 is outside the parentheses. So that means I have 2 OHs. So if I were to draw that for you over here, that would mean I have hydroxide 2 times, which gives me 2 oxygens and 2 hydrogens here. So now that I've determined that, the other thing I notice is that I also have hydrogen in the HCl right here. So I have hydrogen in PbOH2, in HCl, and in H2O. So when I have something in 3 places like that, in more than 2 places in my equation, I'm going to leave that till the end. And I'm going to try to start by balancing something else first. So, skipping over hydrogen, because that looks complicated, I notice that lead, I have 1 in the reactants, 1 in the products. Oxygen, I have 2 on my reactant side, and only 1 on my product side. So I'm going to start with oxygen. 2 on my reactant side, and only 1 on the product side, so I'm going to double H2O. Okay, and then I'm going to wait to deal with hydrogen, so I'm going to look for something else. HCl, so I have 1 chlorine and 2 chlorines on my product side. So I'm going to go ahead and fix that as well. So 2 chlorines, 1 over here, so I'm going to double HCl, 2 HCl. Okay, now let's go back and look at hydrogen. So I have 2 times 2, so I have 4 hydrogens on my product side. And I have, let's kind of make a little caret here. I have 2 hydrogens here and 2 hydrogens there for a total of 4 on my reactant side. So this worked out quite nicely. By starting with other things, we were able to leave hydrogen and it ended up balancing all by itself. So now let's go ahead and check. We know to keep hydrogen at 2, we're going to have to put a 1 in front of PbOH2. And then we need to check lead, 1 lead, 1 lead. So we're going to put a 1 in front of PbCl as well. Next we have AlBr3 plus K2SO4 gives us KBr plus Al2SO4 3. Once again I have a polyatomic, but this time notice I have my polyatomic SO4 or sulfate. I have it on both sides of my reaction. So when I balance, I'm going to think of the sulfate all as one thing. I'm not going to think about how many individual oxygens and sulfurs there are. I'm just going to think about how many sulfates there are. So I'm actually going to start there because I already noticed that there's no parentheses. So I only have 1 sulfate on my reactant side, and I have 3 sulfates on my product side because there's this subscript of 3 outside the parentheses. So to fix that, I'm going to multiply K2SO4 by 3 so that I now have 3 sulfates on my reactant side as well. And then I'm going to look for something else. So now I obviously threw off potassium by putting that 3 there. So now I have 2 times 3, so 6 potassiums. So I need to make there be 6 potassiums on the product side. So currently I have 1, so I'm just going to put a 6 out front of KBr to make 6 potassiums. Now by doing that, I've messed up bromines. Now I have 6 bromines, 6 times 1. 6 bromines on the product side, and only 3 bromines on the reactant side. So to make 6 bromines on the reactant side, I'm going to double AlBr3. Put a 2 in front of there. Now I have 2 aluminums on the reactant side, so I'm going to come over and check on the product side. And I actually already have 2 aluminums on the product side, so I'm just going to put a 1 to finish off this equation. Next I have CH4 plus O2 gives me CO2 plus H2O. And so a light is going off, or a bell in my head. I'm thinking, oh my goodness, this is a combustion reaction. Combustion. And the reason I'm noting this is because combustion reactions can be tricky to balance because they always have oxygen in at least 3 places in the equation. So when we get to a combustion reaction, we're always going to leave oxygen till the end of the equation. We're going to balance oxygen last. And we're going to start by balancing carbon and hydrogen. So here I look and I see, okay, 1 carbon, so that's already fixed. 4 hydrogens. And how many do I have on my product side? Well, I only have 2 hydrogens. So I need to double this. put a 2 there to make 4 hydrogens. Now let's seal with oxygen, and of course I always like to put my caret between the two places that I have an element on the same side of the equation. Okay, so I have 2 oxygens from CO2, and I have 2 oxygens from H2O, making a total of 4 oxygens. So I also need there to be 4 oxygens on my reactant side, and right now I have 2, so I can put a 2 out front. 2 times 2 gives me 4 oxygens. And last but not least, I'm going to fill in my 1 next to CH4. Okay, moving on to number 8. So once again, I have a combustion reaction here. I have a hydrocarbon plus oxygen gives me CO2 and H2O. So I'm going to balance oxygen last again, starting with carbon and hydrogen. So I see that I have 3 carbons on the reactant side and only 1 on the product side. So I'm going to put a 3 in front of CO2. Then I look at hydrogen, 8 hydrogens and only 2 on the product side, so 4 times 2 will give me 8 on the product side. Now I'm going to look at oxygen. So drawing my caret here, I have 4 oxygens from my H2O and 2 times 3 is 6 oxygens from my CO2 for a total of 10. And of course 10 divided by 2 would give me 5, so I need to do 5 times 2 to give me 10 oxygens on my reactant side. And then I'm going to fill in my 1 in front of C3H8. Next, I have another combustion reaction. A hydrocarbon plus oxygen gives me CO2 and H2O. So once again, I'm going to end with oxygen, start with carbon and hydrogen. So this time I have 8 carbons on my reactant side and only 1 on the product side. So I'm going to put an 8 in front of CO2. And then I have 18 hydrogens on my reactant side and only 2 on my product side. So what times 2 will give me 18? Well, that would be 9. So I'm going to do 9 times 2 to give me 18 hydrogens. Now let's look at oxygen. So I have 2 times 8, so 16 oxygens from CO2 and 9 oxygens from H2O. 16 plus 9 gives me 25 total. So 25 divided by 2, well, that doesn't give me a whole number. And I know that when balancing chemical equations, I have to have a whole number coefficient in front of each reactant and each product. So there's a problem there. 25 divided by 2 would give me 12.5. And if you're not sure about that, you can use a calculator. You're always welcome to use a calculator in chemistry class. That's going to give us 12.5. And so here's what we're going to do. We're going to go ahead and fill in that coefficient of 12.5. So I'm going to do 25 divided by 2 gives me 12.5. And I'm going to put in 12.5. And then I'm going to finish off by putting my 1 in front of C8H18. But I know that I need all these coefficients to be whole numbers in the end. So in order to make 12.5 a whole number, what I'm going to have to do is I'm going to have to multiply it by 2. And so just like in algebra, I can make a mathematical operation to my coefficients. I just have to make the same operation to all of my coefficients. So I'm going to multiply 12.5 by 2, but I'm also going to multiply 1 and 8 and 9 by 2. And so my new set of coefficients, 1 times 2 would be 2. 12.85 times 2 would be 25. 8 times 2 would be 16. And 9 times 2 would be 18. And so these are my final coefficients, 2, 25, 16, and 18. And I'm going to go ahead and cross off my old ones so it's very clear which ones are the correct ones. 2, 25, 16, and 18. And so this little trick of putting in a decimal value, filling in our coefficients, and then multiplying them all by 2 to get whole numbers, that's a good trick to know for combustion reactions, because you'll run into this problem a lot where you get an odd number of oxygens and you need to put in a decimal and then multiply everything by 2 in the end. Number 10 says FeCl3 plus NaOH gives me FeOH3 plus NaCl. So I have a polyatomic ion, and I have it on both sides. I have hydroxide right here and hydroxide right there. And so the first thing that I notice is that there's a difference in how many hydroxides I have. On my reactant side, I only have one hydroxide, and on my product side, I have 3 hydroxides. So I'm going to fix that. I need there to be 3 hydroxides on my reactant side, so I'm going to put a 3 in front of NaOH. Then I obviously messed up sodium, so I now have 3 sodiums, whereas I started out with just 1. So I have 3 sodiums on my reactant side, so I also need there to be 3 sodiums on the product side. So I'm going to put a 3 in front of NaCl. Then I'm going to check chlorine. I have 3 chlorines now on my product side, because 3 times the implied 1 is 3 chlorines. And I already have 3 chlorines on my reactant side, so I'm just going to fill in a 1. And then now I have 1 iron on my reactant side and 1 iron on my product side. So I'm just going to fill in a 1 there as well. Next, phosphorus plus oxygen gives me P2O5, or diphosphorus pentaoxide. Here I am actually going to start not with phosphorus but with oxygen. You might think you could start with either, and that's true, you can. You just have to be willing to change your coefficients again. But I already noticed that I have an odd number of oxygens on my product side, and that nothing that I multiply by 2 here is going to give me 5. So I need there to be an even number of oxygens. So to get oxygen to an even number, I'm going to start by multiplying by 2 here. 2 times 5 gives me 10 oxygens, so now I can balance oxygen effectively. So that's why I started by looking at oxygen here, because when I put this 2 in front of P2O5, it changed my number of phosphoruses. So if I had put a 2 in front of phosphorus, I would have to end up changing that again, which is totally okay. If you put a 2 here first, and then you end up changing it to what it should now be, which is 2 times 2, which is 4. That's totally fine, but just knowing to look out for those oxygens is sometimes helpful. So 4 phosphoruses, and now I have 2 times 5, 10 oxygens. So what times 2 will give me 10? Well, that is 5. And so this made this a nice, easy balancing problem, just by knowing that we needed an even number of oxygens. Alright, let's look at the next one. So here, I'm looking, and I see that I have hydrogen in 3 places. Hydrogen, hydrogen, hydrogen. So I know I'm going to want to look at that last. So let's look at everything else first. So here I see 1 sodium and 1 sodium. Okay, so that's good. 1 oxygen, 1 oxygen. Okay, so that's good. So now I'm just stuck dealing with hydrogen. So there are multiple places where hydrogen is. So I'm going to connect them on my product side. Currently, I have 2 hydrogens from the H2 and 1 hydrogen from the NaOH. And so that's a total of 3, which is problematic because I have a 2 over here. So I need to multiply something by 2 to give me 3. Or I need to make there be an even number of hydrogens. So what I notice is that this 2 is already an even number. The number that's not even is this 1 hydrogen right here. So if I can make this an even number of hydrogens, then I'll solve my whole problem with hydrogen. So I know that if I multiply something by 2, that'll give me an even number. So that's what I'm going to do with sodium hydroxide. So 2 times 1, so I don't have 1 hydrogen anymore. Now I have 2 hydrogens. And so my total of hydrogens is no longer 3, but 2 plus 2, which is 4. So now I can multiply something by 2 to give me 4 hydrogens. So 2 times 2 gives me 4 hydrogens. So by doing that, we just need to go back and check everything else. So now we fixed hydrogen first, but we might have messed up something else. So 2 times 2 is 4 hydrogens. Now I have 2 oxygens. But I also have 2 oxygens on my product side, and 1 sodium and 2 sodiums on my product side. So I do need to fix sodium, 2 sodium, so I'm going to put a 2 in front of sodium over there. And then I know hydrogen's already balanced, so I'm just going to fill in a 1 over on the product side. Next, Ag2O gives us Ag plus O2. Let's see. So I have two things out of balance. I have silver and oxygen out of balance. Now I can start with either one, and this time let's start with oxygen. So if we have 2 oxygens on the product side and only 1 on the reactant side, so I'm going to multiply by 2. And now I have 2 times 2 is 4 silvers, so I'm going to put a 4 in front of Ag. And then I'm just going to fill in my 1 in front of O2. That's it. Next I have S8O2 yields SO3. Wow, so it's obviously a big difference in number of sulfurs. And I'm going to start there. 8 sulfurs and only 1 on the product side, so I need to put an 8 in front of SO3. So now I fixed sulfur, but now I have a problem with oxygen. 8 times 3 is 24 oxygens. And I only have 2 oxygens on my reactant side. So what times 2 will give me 24? 24 divided by 2 is 12. So I'm going to put a 12 in front of O2. And then I already fixed sulfur. 8 sulfurs, 8 sulfurs, so I'm going to put a 1 in front of S8. Number 15. So this is kind of a tricky one. It's a combustion reaction, but in reverse. So, I have a hydrocarbon, hydrogen and carbon plus oxygen, as products from CO2 and H2O. But I still have the same problem where I have oxygen in more than 2 places. I have oxygen in 1, 2, 3, 4 places. So I'm certainly going to leave oxygen for last. So let's start by fixing carbon and hydrogen. There are 6 carbons on my product side and only 1 carbon on my reactant side, so I'm going to put a 6 in front of CO2. And there are 12 hydrogens on my product side and only 2 on my reactant side. So 12 divided by 2 equals 6, so I'm going to put a 6 in front of H2O. Then I have to fix oxygen. So I'm going to draw my carets connecting my oxygens on both sides. Let's see, I have 2 times 6, so 12 oxygens coming from CO2. And then 6 oxygens coming from H2O. So that's 18 total oxygens. And then on the other side of my reaction, I have 1 times 6 oxygens coming from C6H12O6, which of course is glucose, if you've heard that formula before in biology class. And I need a total of 18, but I don't want to have to change the C6H12O6 because I already balanced carbon and hydrogen. So the rest of those 18 oxygens, I'm hoping I can put something in front of O2 to get me a total of 18 oxygens on this side. So I need to figure out how many more I need. So 18 minus the 6 that I already have, I need 12 more oxygens from right here. So what times 2 will give me 12? Well, 12 divided by 2 equals 6. We already actually did that problem. So I'm going to put a 6 here. So now I have 6 times 2 is 12 oxygens plus the 6, which gives me 18 on both sides. And then I'm just going to fill in my 1 by C6H12O6. Alright, on to the last 3. Number 16, potassium plus MgBr2 yields potassium bromide plus magnesium. The only thing that's out of balance right now is bromine. So I'm going to start with bromine. 2 bromines on my reactants. So I need to put a 2 in front of KBr on the product side. Then by doing that, I messed up potassium. So 2 potassiums on my product side. So I need a 2 on my reactant side as well. And then magnesium's already in balance. So I'm going to put a 1 in front of magnesium. Bromine's already in balance. So I'm going to put a 1 in front of MgBr2. HCl, or hydrochloric acid, plus calcium carbonate gives calcium chloride plus water plus carbon dioxide. So 3 products here. So we have oxygen in multiple places. We have it here in H2O, here in CO2, and in CaCO3. So although I have a polyatomic in this problem, carbonate, I only see that polyatomic on the reactant side. I don't see any carbonates on the product side. So in this case, I'm just going to have to break the polyatomic into its elements when balancing. So I notice I have 1 carbon on my reactant side and only 1 carbon on my product side. I have 1 calcium on my reactant side and 1 calcium on my product side. 1 chlorine on my reactant side and 2 chlorines on my product side, so I need to fix chlorine. So I'm going to put a 2 in front of HCl. And now I'm going to check on hydrogen. 2 hydrogens on my reactant side and 2 hydrogens on my product side. So everything's mostly looking balanced so far. So the last thing that I haven't checked is oxygen. So I have 3 oxygens on my reactant side. And I have 2 here. Oh, plus that 1 that's there. So 2 plus 1 gives me 3 oxygens on my product side. So everything's already balanced. I'm just going to fill in my 1s. The only thing that needed balancing was the chlorine. Last but not least, HNO3 plus NaHCO3 gives NaNO3 plus H2O plus CO2. So I notice that I see NO3 on both sides, nitrate on my product side, so I can keep that polyatomic ion the same. But the CO3, the HCO3, changes. I don't have that HCO3 on the product side, so I will need to keep that separated. So let's see. So NO3, we have 1 on each side. Next, let's check sodium. I have 1 sodium on my reactants and 1 on the products. Okay. Next, let's check carbon. 1 carbon and 1 carbon. And let's check oxygen next, I guess. And this time we're only thinking about the oxygens that are not part of the nitrate. So we kept this nitrate separate. We know it balances with the nitrate on the other side. So we're only thinking about the oxygens that are not part of the nitrate. So I have 3 on my reactant side, and let's see, 1, 2, 3 on my product side. So oxygen's also balanced. And then I think the only thing we haven't checked is hydrogen. So we have a hydrogen here and a hydrogen here, so 2 on my reactant side. And let's see, 2 on my product side, so that's balanced as well. So now I'm just going to fill in my 1s. Everything is already in balance. It worked out nicely.